Entropy and free energy. What are spontaneous physical and chemical processes? A waterfall runs downhill. A lump of sugar dissolves in a cup of coffee. Heat flows from a hotter object to a colder object. And iron exposed to oxygen and water forms rust. These are all spontaneous physical and chemical processes. Spontaneous process would be the ice melting at temperature greater than 0 degrees Celsius. A spontaneous reaction is methane reacting with oxygen to form CO2 and water, or hydrogen ion and hydroxide ion forming water. The expansion of a gas into a vacuum is spontaneous. The reverse is non-spontaneous. Does a decrease in enthalpy mean a reaction proceeds spontaneously? Spontaneous reactions are methane, again, reacting with oxygen to form CO2 and water. The enthalpy change is a negative 890.4 kilojoules. Hydrogen ion reacting with hydroxide ion to form water. The delta H is a negative 56.2 kilojoules per mole. It seems like a negative delta H indicates a spontaneous reaction. Water solid being converted to water liquid, unfortunately, has a positive delta H. And ammonium nitrate breaking down into ions, again, has a positive delta H. Clearly, delta H cannot be used to decide whether a reaction is spontaneous. We introduce a new thermodynamic term, entropy. It is a measure of randomness or disorder of a system. If the order increases, the entropy decreases. If the disorder increases, then the entropy increases. The change in entropy is the final entropy minus the initial entropy. If the change from initial to final results in an increase in the randomness, then the final will be greater than the initial, and delta S will be greater than 0, that is positive. For a substance, any substance, the solid state is more ordered than the liquid state, and the liquid state is more ordered than the gaseous state. So solid has less entropy than a liquid, which has much less entropy than a gas. The conversion of solid water into liquid water, melting ice, has a delta H that is positive. Delta S that is positive, that is. Entropy is the change, again, from the final entropy to the initial entropy, and is a measure of randomness or disorder. The important thing to remember is delta S increases for a spontaneous process. Here's an example. Bromine liquid being converted into bromine gas. Delta S is greater than 0. Another example is I2 solid becoming I2 gas. Again, delta S is positive. How does the entropy of a system change for each of the following? The condensing of water vapor. The randomness decreases, so the entropy decreases. Delta S is going to be negative, less than 0. Forming sucrose crystals from a supersaturated solution. Randomness decreases, entropy decreases, delta S is going to be less than 0. Heating hydrogen gas from 60 to 80 degrees. Here the randomness increases, more energy in the system. The entropy increases, delta S is greater than 0, positive. Subliming of dry ice. Randomness increases, the entropy increases, delta S again is positive.